last one, I could tell, is going to take a little bit longer, and I needed to make sure that I had enough room, so that's why I wanted to start over. Okay, so whenever we did adding and subtracting, we always had the phrase factor first, factor last. So we want to do that right here because that will help us decide on what that common denominator is so that we don't have to do more than we think. So again, looking at the left side and looking at the right side, we notice that we have two fractions over here, so we cannot cross multiply. We have to go ahead, factor, get the common denominator, and then we can throw it out once we've adjusted everything. So let's first just, okay, if you factor this is kind of our easier factoring. X squared minus 9 is a pattern. So what would that denominator change to? It would change to plus 3 and minus 3. Alright, so that, and I just went ahead, instead of doing everything, I just crossed it out. We're going to look at this instead of at that. Alright, so now when you look at your common denominator, okay, this one has an x minus 3, so it is missing the x plus 3. This one's got both, so we won't have to we don't have to deal with that one, it's already ready. And then this one is missing the x minus 3. So the common denominator, if you want to kind of have it in mind, let's see if I can write it over here. The common denominator would be x plus 3, and x minus 3. Alright, so that means all three of them have to have that. And again, you can ask yourself, well, what is it missing? So, if this original fraction was 6 over x minus 3, we decided that it is missing the x plus 3. So, let's put the x plus 3 in here and on top. Alright, now it matches the common denominator, now it matches that one, so we'll be able to throw it out in a second. We already said this one, we don't have to adjust, it is ready, 8x squared, so it already has x plus 3 and x minus 3, but now I'm just going to say plus a negative 4x, because that way, actually, now I can leave it as minus. So minus, just don't forget about it. This fraction, let me use the pink. Alright, this fraction is 4x and x plus 3. We already decided, I already mentioned that it's missing the x minus 3 from the common denominator, or compared to that one since it had it all. So let's multiply x minus 3 on top and on bottom. Now they all match each other. So the numerators are going to adjust, but now the denominators all match. So in order to solve, we can now get rid of them. We can multiply both sides by x minus 3 and x plus 3, and it would get rid of them. That's what happens when you do things to both sides. That's why you do things to both sides, is to get rid of things so that you can solve. So let's just go ahead and say, okay, let me get rid of these denominators. So now let's focus on solving the numerator. So when we distribute, we get 6x plus 18 equals 8x squared. That's a red flag. Probably going to have to factor. Minus, and now let's distribute. 4x times x is 4x squared. And be careful, a negative 4 or minus 4x times negative 3 is actually a plus 12x. Okay, the negative here times the negative there is going to change that to a plus. So again, we do have an x squared. That means we are going to have to factor. And we need to say equals 0. I'm actually going to move things over here. That way the x squared is positive. So 8x squared minus 4x squared is 4x squared. We're going to have to do the long factoring, unfortunately. 12x minus 6x is 6x. And then I'm going to subtract the 18 over to this side. So what I did was I subtracted those two over here. 6x I subtracted from 12x. 18 I just tacked onto the end. Now, before we factor, or the first thing of our factoring is always GCF. So when you look carefully, the GCF is a 2. So that's 2x squared plus 3x minus 9. So that will make our factoring at least a little bit easier. Okay, if you want to divide the GCF out, you could, because you could divide both sides by 2. It wouldn't change the 0, but it will make this easier to factor. 2x squared plus 3x minus 9, all right? So this is going to take us, this is our two-step factoring where, and hopefully you have some room down below. I can't scroll because I don't want to move it, so I'm just going to move mine off to the side, where we say, okay, what multiplies to that? Multiply negative 18 and adds to 3. Well, thank goodness it is a 6 and a negative 3. Okay, that way it actually did give us numbers. We didn't have to use like the quadratic formula or anything like that. That would have been an even longer process. So those, remember, go into our box. Okay, and we factor by grouping 2x squared, negative 9, and then these two are in here, 6x and negative 3x. So our GCFs are x and 3, 2x and negative 3. Those multiply together, so those are our factors. 2x minus 3 and x plus 3. All right, and then remember, our solutions are the opposite, but because this one's a two-step equation, it's the opposite and the denominator. Okay, so it would be the opposite of 3, but we would also have that as the denominator. Because if you were to solve that, you would add 3 over, divide by 2, and you'd get 3 halves, and you would get a negative 3. You'd subtract 3 if you were to solve, and you'd get a negative 3. So there is the overall solution. Remember, at the end, we always want to look for extraneous, anything that could make a 0. So if you put 3 over 2 in here, 3 over 2 won't cancel a 3 out, and it won't cancel a positive 3 out, so that one's good. But if you put a negative 3 in here, negative 3 minus 3, that's negative 6, that one's okay. But if you put a negative 3 right here, that would cause us a problem. So this negative 3, what color? Here we go. All right, so this negative 3, if we were to put it right here, negative 3 plus 3 would give us 0, and we don't want that. We cannot get 0. So this negative 3 is not a part of the answer. It is just the 3 over 2, okay? Because now we have to keep those fractions in mind. So hopefully we'll practice that a bunch, and you'll get comfortable with it. The nice thing is you get rid of the denominators once it matches. So all you have to do is go back to everything we know about solving, okay?